Section 6.6, we're going to build on solving absolute value equations and transition into solving absolute value inequalities. So while a lot of the methods are the same, you're still going to be looking at positives and negatives, but obviously with inequalities, that changes a few things because now we're no longer just dealing with an equal sign. Okay, so recall this is the previous lesson here. Remember the absolute value of x equals a. What that means is it means two different things. You branch off to either x equals a or x equals the opposite of a. So for example, if the absolute value of x equals 6, then what that means is that x either equals 6 or x could be negative 6. Either solution will work there in that absolute value equation. Today, we're going to look at solving absolute value inequalities. Okay. Now, here's what you need to understand is that if the absolute value is less than a number, then this is the inequality that you're going to write. Okay. So for example, if it says the absolute value of x is less than 6, that tells me I have 6 and I'm also working with negative 6. And so very simply put, all I do is go negative 6 less than x less than positive 6, and I'm done. Okay, so x has to be between negative 6 and positive 6 in order for this inequality to be a true statement. Okay, the opposite is true if its absolute value of x is greater than a. Okay, and so for that one, what you have to do is not only do you have to take the original, right, x greater than a, or x is less than negative a. So the easy way to think about this is you take the original, just like you did with an equation, right, and then what you do is you flip the inequality and take the opposite. All right, so this one's going to take a lot more getting used to, but in other words, what you'll do, you have two things here. You have x is greater than 6, or x is less than negative 6, and those are your two separate inequalities there. So really it comes down to identify, is it an and or is it an or, and it's all based on what this inequality is. If it's greater than, it's an or. If it's less than, then it is an and. So example number 1 says solve the inequality or equation, then graph the solution. Okay, so this is less than. Okay, so what that means is that x is between negative 4 and positive 4. Okay, so we'll go by 2. So 0, 2, 4, negative 2, negative 4. So close circle, and there's my graph. Okay, again, it's between, it's an and. Part B is an or because it's greater than. So what you say is you say x greater than or equal to 10, or x, and then flip it, less than or equal to negative 10. So we'll call this guy 10 right here. So x is greater than or equal to that. Shade everything to the right. Or if that's negative 10, it's everything less than or equal to that guy. Okay, so the graphing part shouldn't be anything new. You should already know how to do that. Part C, it's an and because it's less than. So I know I have negative 1 less than x minus 3 less than 1. And then I just solve this the same way I solved inequalities. Okay, add 3 to everything. I get 2 is less than x is less than 4. So there is your final inequality. Part D, it's an or because it's greater than. So x minus 3 greater than 1, or x minus 3 is less than negative 1. And then again, you just solve these separately. So either x is greater than 4, or if I add 3 over here, that says that x could be less than 2. Okay. So in order for the inequality to be true, either x has to be bigger than 4 or it has to be less than 2 in order for the absolute value inequality to hold true. Okay, part E here is review. Okay, it's an equation. So remember, you branch off to two things. You have 2x minus 6 equals 10, or 2x minus 6 equals negative 10. Okay, and in both cases, you're going to go ahead and add 6 to both sides, and then divide by 2. So x is negative 2, or when I add 6 and divide by 2 over here, you're going to get x equals 8. So either x is 8 or x is -2. And when you graph that solution, you go to -2. X is either that guy only, or it could be, let's see here, 0, 2, 4, 6, 8, or it could be 8. And that's the graph right there. That's it. Okay, those are the only two values that you can be. Part F, at this point, I would probably pause the video and see if you got this on your own. But I'll do it. Again, it's an and inequality because it's less than, so I have -9 less than 2x minus 7 less than 9. I'm going to add 7 to everything. So I get -2 less than 2x is less than 16. And then divide everything by 2. You'll get -1 is less than x is less than 8. And you, again, at this stage of the game, should know how to graph that, so I'm not going to spend the time in this video doing that. Okay. Again, I think most of these I'll do. Those two are pretty straightforward. I'm gonna let you guys handle those on your own. Shouldn't be an issue. Okay. Part 4 or example 4 is a little bit different as far as the extensiveness of the problem. So again, same process. You still want to get the absolute value by itself. Okay. So I have the absolute value of 2x plus 3 is less than or equal to 9, and now you're right back to square one, what you've been doing all, in the previous examples. It's less than, so it's an and, so you have -9 less than or equal to 2x plus 3 less than or equal to 9. Subtract your 3 from everything, so you have -12 less than or equal to 2x is less than or equal to 6, and then just divide every single term by 2. And you end up at -6 is less than or equal to x is less than or equal to 3. And again, we're not gonna graph it. Part B, again, at this point, you should be pretty comfortable or at least have somewhat of an idea. So I would pause the video and see if you can do it on your own. Since it's greater than, that means it's an or. So I'm going to get my absolute value by itself first, though. So the absolute value of x minus 6 is greater than 3. And so the two things that you have x minus 6 greater than 3, or x minus 6 is less than -3. And then you solve these two things separately. So x is either bigger than 9 or x is less than 3. One of the two. Oops. And so again, this idea of absolute value inequalities really comes down to identify, is it an and or is it an or inequality? Okay, so I've done quite a few examples already in this video. I think that's probably sufficient. So if any questions do arise, I do want you to try parts C and D on your own. So when we come in tomorrow, if I were to walk around and take a look at your notes, obviously those should be done, and hopefully they're done correctly and you're on the right track. But again, if you have an issue with these and you start doing them and you're running into a roadblock here or there, then obviously bring those questions to class and we'll handle those tomorrow.